In this video, we are going to take trig identities and we are going to learn how to simplify their expressions. So the ways to simplify identities is one way. This is not going to work all the time, but I would say probably 95% of the time, if you were to rewrite everything in terms of sine and cosine, that will help you to be able to simplify the expression. The second thing to look for is Pythagorean identities that we've discussed in the past, which is the sine squared plus cosine squared equals 1, or their identities that will come from that. And then 3, when dealing with fractions, always try to look for common denominators. So as an example, what we're going to do is we're going to simplify this identity. So for example, I want to try to simplify this identity. So the first thing I'm going to do is I'm going to take cotangent and I'm going to replace it with the quotient identity, which is cosine divided by sine. And that is being multiplied by sine. And now I notice that there is a sign on the denominator and a sign on the numerator. So if I divide out a sign, they will cancel, leaving me with my answer of cosine theta, in which we have now simplified. So in this case, let's try to do this again with tangent times cosine. And so what we are going to do is take tangent and we are going to rewrite it as the quotient identity. And we're going to multiply that by cosine and then see if there's anything that cancels. And there's a cosine in the denominator and numerator. They cancel, leaving you with what is left, which is sine of theta. Now in this one, 1 minus cosine squared divided by cosine squared. There is 2 ways you can do this, and either way is fine. You can either first notice that this is a Pythagorean identity, or you could break this up into 2 fractions. It doesn't matter which one. I know that the identity of cosine squared plus sine squared equals 1, which means I can get this identity to become something like this. So in order to make this look like the numerator, I realized that they subtracted cosine squared. So if I subtract both sides, I will be left with sine squared on the left, and on the right, I'll be left with 1 minus cosine squared, which is exactly what the numerator is. So I'm going to substitute, instead of 1 minus cosine squared, I'm actually going to substitute what it equals, which is sine squared. And now I have sine squared divided by cosine squared, which is itself a quotient identity of tangent squared. Next, we're going to do this again. We have cosine multiplied by cosecant. So one thing I'm going to go ahead and do is I realize that cosecant is the same thing as 1 over sine. And I'm going to bring down my cosine. So I'm going to rewrite this as 1 fraction. Cosine is in the numerator, and I have sine in the denominator. And now this is a quotient identity. Cosine divided by sine is the expression cotangent of theta. So in this one, I'm going to go ahead and rewrite everything in sines and cosines. So I will have sine theta. And then secant is 1 over cosine theta. In the denominator, I have sine theta because tangent is a quotient identity. So now I'm going to rewrite the top in 1 fraction. So I have sine divided by cosine all over the exact same thing. And so therefore they both divide out of each other, and your answer is the number 1. You actually have canceled all the identities and trig functions. So for the next one, I'm going to rewrite these. Cosecant is 1 over sine. Cotangent is cosine over sine. Now, you have a fraction divided by another fraction. And so something that I teach when you have fractions inside of fractions is something called KFC. In case you're not sure that the fact that sine and sine will cancel, I'm just going to show you why. So what happens, KFC, is I'm going to rewrite this using the division symbol. K stands for keep it. F stands for flip the second fraction. And C stands for change the sign. Now we can see what cancels. We have a sign in the denominator and a sign in the numerator, which will leave us with 1 over cosine. And 1 over cosine is the reciprocal function of secant. Now, in this next one, I'm going to rewrite everything again in sines and cosines. So I have sine of theta. Tangent is the quotient identity of sine over cosine. Cotangent is the quotient identity of cosine over sine. And cosecant is 1 over sine. And now let's see what all will cancel. I have a sine in the numerator and denominator. They divide out. I have another sine divided by sine. And I have another cosine divided by cosine. So our answer is, again, the number 1. So from here out, I'm going to continue just to be working through different simplifying expressions and how to work through those. So at any time, if you would like to just pause the video, attempt to do these problems, and then resume, I'm going to show the answers and how to get to the answers for the following slides. So beginning with this, again, I'm going to put everything in terms of cosine and sine. That is a quotient identity. And then see what cancels, which the sines cancel, leaving me the identity that's left, which is cosine. In this one, this is a Pythagorean identity, which is actually the number 1. Sine squared plus cosine squared equals 1. And then on bottom, I still have the cosine squared. And 1 over cosine we know is secant. And so this is secant squared of theta. Now the next one, so we have 2 fractions that are subtracted. So I am going to go ahead and first switch everything into sines and cosines first. Cosecant is 1 over sine. And then on bottom I have sine. Cotangent is cosine over sine. And tangent is sine over cosine. Next, I am going to do KFC on both of these so that I can get 2 basic fractions together. So if I was to do 1 over sine divided by sine, that is keep it, flip it, and change it, which is 1 over sine squared. For this one, I will get cosine over sine divided by sine over cosine, which is keep, flip, change to multiplication, which would be cosine squared divided by sine squared. Now at this point, because the denominator is the same, I can go ahead and combine into into 1 fraction. And I notice that this is a Pythagorean identity. Again, Pythagorean identity is cosine squared plus sine squared equals 1. So I know that if I was to subtract cosine on both sides, I would get this identity, which is sine squared. And on bottom, I still get sine squared. And so they divide out, leaving you the number 1. This is actually a polynomial. Think of it as difference of perfect squares from first semester of pre-cal. So this you can actually factor into sine squared minus cosine squared times sine squared plus cosine squared. Now we know this right here is actually an identity, which is actually the number 1. So this goes away because it's just 1. This is another difference of perfect squares. This can actually factor again into sine plus Now this is also a difference of perfect squares, and so I know that you can factor it again, but I notice that when I do that, nothing helps. Like there's no identity that I'm aware of that deals with just sine and cosine. So that actually did not help me. You can leave the answer like this, or you can notice down here, we noticed that sine squared is 1 minus cosine squared. So I can actually take sine squared and replace it with 1 minus cosine squared. And then I'm going to bring down the minus and bring down the cosine squared. And then this becomes 2 cosine squared. That is the only way you can simplify this further if you choose to, or you could have left it like this. There is a way to have replaced the cosine instead, but this will give you one of your answers. In this, I'm going to replace everything with sine and cosine. So I have sine plus, I'm going to go ahead and just not use the thetas until the end. Now I'm going to take the numerator and make a common denominator. So if I need to multiply the bottom by cosine, I need to multiply the top by cosine. And so this will give me sine times cosine plus sine on top. And then in the denominator, if I want to multiply the bottom by cosine, I got to multiply the top by cosine, which will give me cosine plus 1 all over cosine. Now, I have cosine in the denominator up here. I have cosine in the denominator down here. They will cancel, leaving me one fraction. On top, I'm left with sine times cosine plus sine. And on bottom, I am left with cosine plus 1. Now, we are not done. I know this looks weird, but I notice that there is something that can be factored out of the numerator. There is a sign in both terms. So using algebra 2, if I pull out a sign, if I factor a sign out, then I'll be left with cosine plus 1 out of the top, because I pull a cosine and I pull the cosine. And in the denominator, I also have a cosine plus 1. They will cancel, leaving me my answer of just sine theta. Now in this one, there is a trig identity. A Pythagorean identity. We know that sine squared plus cosine squared equals 1. I also know that if you divide everything by sine squared, you will get 1 plus cotangent squared equals cosecant squared. That doesn't really help me because I have cotangent squared, but I don't have cosecant squared anywhere. So that did not help. So instead, I'm going to divide everything by cosine squared. I'll be left with tangent squared plus 1 equals secant squared. Okay, that gives me something that almost looks like this. I have secant squared and tangent squared on the same side, so I need to subtract tangent squared on both sides, leaving me 1 equals secant squared minus tangent squared. Well, this secant squared minus tangent squared is the number 1, so I'm going to replace this with the number 1 and then bring down cotangent squared, which, again, I believe is an identity. That is actually cosecant theta from our So what happens is this sine squared is going to divide out by both those sine squares, leaving me what is left, which is cosine of theta. So I know that this is an identity. Wait. This is almost the identity. We know that sine squared plus cosine squared equals 1. But this is cosine squared minus 1. So if I need to subtract 1, that means I have to subtract sine. So if I subtract sine squared on both sides, I will get cosine squared equals 1 minus sine squared. And now I need to subtract 1. So cosine squared minus 1 equals a negative sine squared. So they're opposites. So this is actually a negative sine squared of theta, which means this is a negative cosine squared of theta. And two negatives cancel, and sine over cosine gives you tangent squared of theta. I'm going to replace everything with sines and cosines. And I need a common denominator. There is not a common denominator, so I got to multiply by sine, and I got to multiply this by cosine in order to get the same denominator. So the top I'm not going to do anything with, but at the bottom I'm going to get sine squared plus cosine squared all over sine times cosine. Now from there, I know this is an identity. So on top I have sine cosine. In the bottom, that becomes 1 over sine cosine. Now I'm going to do K of C. So keep divided by 1 over sine times cosine. So I'm going to keep, I'm going to flip and change and see what cancels. I have a cosine in the denominator and the numerator, so they cancel. The sines are both in the numerator, so you just multiply them to get sine squared. This is an identity. It is cosine squared, and then I'm going to replace this with cosine squared divided by sine squared, and then I'm going to do K of C. This is the numerator. This is the denominator. And K of C means keep, flip, change, and see what cancels. Cosine and cosine cancel, leaving me just sine squared. For the next one, there is no common denominator, so I'm going to have to multiply by each other. So In the numerator, I'm going to have a 1 plus cosine plus a 1 minus cosine. In the denominator, it is 1 minus cosine times 1 plus cosine. I'm going to go ahead and take the numerator. Cosine minus cosine is 0. 1 plus 1 is 2. And I'm going to FOIL the denominator. And when I do that, I get 1 minus cosine squared, which thankfully is an identity, which is sine squared. So you can either leave your answer like this, or when you have sine in the denominator, that is the same thing as cosecant in your numerator. So both of those would work. Next, there is no denominator, so therefore I'm going to have to multiply the bottom and top in order to have a common denominator. So in the top, I'll have tangent squared minus secant squared. And on bottom, I have tangent of theta. Now, this is also an identity. It is actually the number 1. So 1 over tangent is the same thing as cotangent. And if you're not sure about this identity, secant squared minus tangent squared, we realized was 1. So therefore, this should actually be a negative 1, which means this is a negative cotangent. And last, now with this one, something nice happens. This is actually an identity. Again, sine squared plus cosine squared equals 1. So if I need to make cotangent, that means I have to divide everything by sine squared, which gives me 1 plus cotangent squared, and that equals cosecant squared. So 1 plus cotangent squared, that is cosecant squared, and I multiply that by sine. And now I'm going to replace this with sine. So cosecant is 1 over sine squared. And see what cancels? This sine cancels with one of those signs, leaving me 1 over sine theta, which is cosecant theta. And last, we need to figure out a trig identity. We know, I think I can make one. So if I need to get this to look like this, I would subtract cotangent squared from both sides. And it gives me 1.